So, I've been thinking, if you've been making games with Godot for the last few years, you've probably noticed something interesting. With every new release, game development is becoming easier and easier. We've got better rendering, better tools, better workflow, and now that AI is starting to help us write code, generate assets, and even build entire game prototypes, the questions that sounded ridiculous just a few years ago suddenly feel more realistic. Questions like, will we still spend hours writing GDScript, or will we still be building every system by hand? And will solo developers still be creating games the same way they do today? Now, with us getting closer to ideas like artificial superintelligence and artificial general intelligence, the real question is, what will making games with Godot look like in 2030? But here's where I think things really get interesting. Now, this is just my opinion based on research I've done and a little survey I did on my channel recently. The rumors split, but I think that the future of game development is not just simply more AI slop. And with every major technology shift, much more changes than just the tools we use. It changes how the games we make are designed. It changes what skill developers need. And sometimes it completely changes who can actually make games in the first place. Therefore, if Godot continues evolving at the pace we've seen over the last few years, the way we build games by 2030 could look radically different from what we're doing today. In this video, we're going to explore 4 of my predictions for the future of Godot. From AI-powered development to automated asset creation to real-time collaboration and the possibility that coding itself may no longer be the most important skill for indie developers. Now, I know that last one probably triggered a lot of you out there, but I just ask you to hear me out. I'm not going to try to push an agenda or convince you either way. I'm just trying to take an objective look at the situation. So what does the future of game development in Godot actually look like? I'm D, and this is D-Ragu Games. Let's get started. Now, before you roll your eyes at me and think, great, another AI prediction, please hear me out. The reason I think this is likely isn't because of something that might happen in the future. It's because it's already happening right now with tools like Ziva AI. And just to be clear, Ziva is not sponsoring this video. Today, Ziva can write GDScript, help debug errors, read your project structure, create scenes, generate assets, and even interact with parts of the editor itself. Now, think about that for a second. Just a few years ago, if you wanted help with your project, you had to search through documentation, browse forums, watch YouTube tutorials, or ask questions on Discord. Today, you can simply ask an AI assistant. And I'm not saying this to discredit the thousands of developers that have been studying and improving their skills over the years that are now losing their jobs to AI as you watch this video, or to all the YouTubers that created Godot tutorial-based content that now think of their channels as redundant. This video is neither here nor there when it comes to AI. AI is getting to the point where it doesn't just explain things, it can actually help build them. But this doesn't mean that we don't need developers or content creators in the space anymore. It just means that we all need to evolve with the technology. The open source community is already experimenting with similar ideas. Projects like Godot AI Assistant Hub are exploring ways to connect AI models directly into the editor. Now, that's a huge shift because for years, AI tools were mostly glorified autocomplete systems. You would ask a question, get some code, and then manually copy and paste everything into your project. Now we're moving to something completely different. We're moving towards an AI that actually understands the engine, an AI that understands your project, and eventually an AI that understands your goals. Imagine opening Godot in 2030 as a construction worker and typing, create a simple platformer with a player controller, health system, collectibles, and a pause menu. And instead of generating a wall of code, the AI could create scenes, set up nodes, connect the signals, generate placeholder assets, and give you a working prototype in just minutes. Now, does that mean game development becomes effortless? Far from it. We still need to avoid the infamous AI slop. Someone still needs to design the mechanics, balance the gameplay, and create a relatable human experience by making important creative decisions. But now the amount of time spent on the repetitive tasks and research could shrink dramatically because once AI can help build interesting systems, create assets, and automate large portions of the repetitive development, it changes what developers spend their time doing. And instead of building every feature from scratch, we may spend more time refining our ideas. And if that happens, AI won't replace game developers. I believe it will amplify them and make game development more accessible to everyone more than ever before. The solo developer of 2030 may be able to accomplish what currently requires a small team. And that's exactly what leads us into my next prediction. One of the most interesting directions this is all heading in is collaboration. Right now, Godot doesn't really have a true Google Doc style collaboration workflow built directly into the editor. You know what I mean, right? It works, but it's not exactly real-time collaboration. But that's starting to change. There are a few early projects that hint where all this is going. One of the most interesting examples is IMS creators. They reached out to me about their product. And just to be clear again, IMS is not a sponsor of this part of the video either. And I haven't done a deep dive into their system yet, but it's definitely got my attention. In a nutshell, what IMS is trying to do is basically move beyond just being a game engine tool and instead become an all-in-one development workspace. Things like game design documents, world-building tools, dialogue editors, task boards for teams, project analysis, and even Godot export integration. If that's something you want me to explore in a future video, let me know in the comments. So instead of just focusing on building inside the engine, it's trying to centralize the entire development pipeline in one place. And IMS isn't the only attempt at this. There's also early community work like GD Collab, which is experimenting with live collaborative editing, meaning multiple developers inside the same project at the same time. Then you've got tools like GameScript, which focuses more on collaborative, narrative, and dialogue systems, letting teams work together in real time on story content that plugs directly into Godot. There's also Level 1, which pushes things even further into cloud-based development. Things like prompt-to-game generation, shared projects, and browser-based workflows. And on the back-end side, platforms like GD Sync are solving different parts of the same problem. Things like multiplayer systems, cloud syncing, leaderboards, matchmaking, basically removing the need for every team to build all of that from scratch. Game development is still surprisingly fragmented. What if all that lived in one place? If you look at where things are heading, especially as AI and collaboration tools continue to improve, the future may look less like developers working in separate apps, improving version control. And that's a really big deal for indie developers, because as more of the friction around collaboration disappears, small teams gain the ability to build things that once required much larger studios. The real proof is already here. Small teams aren't experimenting anymore. They're shipping successful, polished games that compete on the same storefronts as much larger studios. Take Domekeeper, for example. It didn't start as some massive studio production. It came from a very small core team, and it actually began its life as a game jam prototype. That's important because game jams are usually where ideas die off or get archived. But in this case, the idea didn't stay small. They took that prototype, polished it, and eventually turned it into a full commercial release that made its way onto Steam and consoles, and became a well-known indie success. What's interesting here isn't that the game succeeded, it's how few people it took to actually get there. Now compare that with something like Halls of Torment. This one comes from a small indie studio, not a large team by any traditional game dev standard, but the result looks and feels like something far bigger. just a small team executing really well with modern tools. And that's the pattern that keeps showing up. Small teams building big results. Tools like Godot combined with better collaboration systems and eventually AI assisted development. Now, I'm not saying that these devs used AI at all. What I'm saying is that eventually AI assisted development could remove a lot of the traditional bottlenecks that used to require large teams. And if you project that forward to something like 2030, the difference becomes even more extreme. Instead of needing a 10 to 20 person team, you could realistically see a small core team working inside a shared development environment, real-time collaboration directly in engine. In that world, a small team doesn't mean limited anymore. So when you look at games like Domekeeper and Halls of Torment today, they're not just success stories, they're early signals. Proof that the bottleneck is no longer can small teams build big games. It's becoming how much bigger can the games that small teams make when the friction disappears entirely. One of the biggest questions that keeps coming up is pretty simple. Will coding still even matter? Because if AI can generate scripts, build systems, and even structure entire projects, it's easy to assume that programming as a skill is slowly being replaced. But history doesn't really support that idea. In fact, I've found that every major shift in software development has triggered almost the exact same concern, and each time the conclusion has been surprisingly consistent. Okay, let's go back. In the early days, programmers were writing everything in something called assembly language, directly interacting with hardware instructions. Then came higher level languages like C, and at the time, a lot of engineers genuinely believed this was a step backward in skill. They believed that abstraction, which is the process of hiding complex details so you can use something without needing to really understand how it works internally, would create weaker programmers. People who truly didn't understand the machine anymore. But what actually happened was the opposite. Programming didn't disappear. It actually expanded. So abstraction didn't remove skill. It actually changed what skill meant. Then in the 80s and 90s, we saw the rise of object-oriented programming. Languages like C++ and Java introduced us to concepts like classes, inheritance, and encapsulation. And again, there was pushback. Even people who criticized it still use its concepts every day, sometimes without even thinking about it. Then came the internet shift in the 90s, popularized by Tim Berners-Lee. Desktop developers looked at early web applications and thought, this is way too limited to ever replace real software. But the web didn't need to be powerful in the same way. It changed the distribution model entirely, and suddenly, software didn't need installation anymore. It just needed a browser. By the 2000s, frameworks and engines started taking over. And again, there was concern that developers were becoming framework users instead of real engineers. But what actually happened was a massive increase in productivity. Small teams could suddenly build systems that used to require entire departments. Then cloud computing arrived, and once again, the same debate appeared. If you're not managing your own servers, then are you really an engineer? And if you take a step back and look at all of these shifts together, a pattern starts to emerge. I mean, really, every major transition follows the same cycle. First, people say the new abstraction will reduce real skill. Then they say it makes systems too complicated or too detached from the fundamentals. Then there's a fear that developers will start losing the understanding of how things actually work. But you know what? Despite all of that, adoption still continues, and the role of the developer doesn't disappear. It actually evolves. And that's where this directly connects to AI. Because AI is just the next step in that same pattern. It's another abstraction layer, one that changes how we interact with code, not whether the code exists at all. So instead of asking, will coding still matter? A better question might be, what does coding become when this other layer of abstraction sits on top of it? Because if history is anything to go by, then the pattern stays the same. Coding doesn't disappear. It shifts upward from writing every single instruction manually to designing systems to orchestrating frameworks and now to working alongside AI. Each time that shift happens, the definition of being a developer changes. But you know what? The need for developers has never actually gone away. If this video made you stop and think about how you're learning Godot and not just what you're building, then you're exactly who this channel is for. I make videos for developers who want to understand their code and have the discussions that tackle the difficult topics. So if that sounds like you, hit subscribe. You'll feel right at home here. And before you go, answer this in the comments. Would you still learn programming from scratch if AI could write most of your code? I'd really like to know. Until next time, happy coding, keep experimenting, and I'll see you in the comments. This has been D-Ragu Games.